here's a couple quick variations, some AP kind of problems. Okay, now we can kind of simplify that a little bit to all those little steps to say this. We said y new was the y old plus it was delta y. And delta y was just delta x times the slope. Okay, so we can also say this, y2, or let's say it as y n plus 1, meaning the next one, is yn, meaning the previous value, plus m times delta x. Okay, you can almost see this as y equals kind of like mx plus b. Okay, there's a relationship. Okay, so how can we use that there? All right, well, let's see here. Let's erase this thing. Let's use this idea here. Okay, move it on up. So here we have a situation where we're given the value of f and f prime at certain x values. We want to use Euler's method and 2 steps. Notice there's 2 steps to approximate f of 2.6. All right, so what we need to do is we have this first value when x is 3, y is 2. Okay, so to find the next y value, y of n plus 1, the new y value, let's take the old y value 3 plus the slope is the derivative, 0.4, times delta x. Now what is delta x? Well, 2 equal steps here. So we have 2.6 minus 3. We're going from 3 to 2.6 divided by 2 steps. This is our delta x. All right, and so that's negative 0.4 divided by 2. That's negative 0.2. Okay, so there we have it. All right, so this is 3 minus 2 times 4 is 8, but we're going to move the decimal one place, 0.8. So 3 minus 0.08 is 2.92. Okay. All right, well, let's find the next one. The third point, I guess we could call this is the second y value. First y value being what we started with there. And so the third y value would be y2. That'd be this one here, 2.92, plus the slope. Well, the slope at this point is 0.7. Okay, so our slope is 0.7 times delta x, which is negative 0.2. All right, so we have 2.92 plus 0.2 times negative 0.7. You can probably just go to your calculator for that. This would be a minus 0.14, it should be there. And so if we subtract 0.14 from that, we should have 2 points. Let's see, subtract 10, we get 82. Subtract 4, we get 78. So 2.78. All right. So there you have it. So our approximate is f of 2.6 is approximately 2.78. All right. That's the idea. Okay. One last one here. All right. So here's a table giving us the rate of change for these different x values. Okay, and the directions say the table left gives selected values for the derivative of a function g on the interval from negative 2 to 1. If g of negative 1 equals negative 2, and Euler's method is a step size of 1.5 is used to approximate g of 2, what is the resulting approximation? So you might find it useful to have a g of x column here. And we'll start with putting our negative 2 in here. Now we've got to watch out. We're going by 1.5s. So we're going to go from here from -1 to 0.5, and then from 0.5. So we're not going to fill them all in. So we have G new equals G old plus the slope times delta x. So let's try that out. We've got -2 plus the slope, which is 2, times delta x, which is 1.5. And that's going to be -2 plus 3, that's 1. So when we jump to here, we get 1. Okay, we're just skipping all this. And we got one last one. We start at 1. We have a slope of 1. And 1.5 is our step size. So that's 1 plus 1.5, and that gives us 2.5. So our approximation is 2.5. Got to be careful. We're not finding all of them here. We're just using the step size given to give that answer. And there you have it. All right. So the new is the old plus the slope times delta x. All right. Great job. Keep it up. Thanks a lot.